We're now going to look at logarithmic differentiation. And so we want to take the derivative of y, which is equal to x to the fifth, divided by 1 minus 10x multiplied by the square root of x squared plus 2. And so we can take the derivative of this term by using normal means, such as the quotient rule and the product rule, but that's going to leave messy algebra. There's a lot more room for mistakes. And so one simple way to take the derivative is to use the logarithmic approach. So we'll take the natural logarithm of both sides. And then after doing that, we can go ahead and expand this right-hand side using the properties of logarithms. And so when we have a top term or a division symbol, we can take the natural logarithm of the top and subtract it by the natural logarithm of the bottom. That's one of our properties for expanding logarithms. And then we can look at this multiplication term and we can separate these two terms by taking the natural logarithm and adding them. But one key thing here is that we have a subtraction symbol, and this subtraction symbol is going to factor into both terms, which is why we have a subtraction symbol here as well as here. Now we have something that's a little bit easier to approach from a derivative standpoint. And so we'll go ahead and take the derivative and solve for y prime. So we'll take the derivative of the left-hand side, and then we'll take the derivative of the right-hand side using our standard logarithmic differentiation approaches. And so after a little bit of simplification with our x terms, we're left with 5 over x. And then these two, negative symbols are going to combine. So we have 10 over 1 minus 10x. And then we can go ahead and simplify this term to get x divided by x squared plus 2. And the last step is we can go ahead and multiply this y term to the right-hand side. And then what we want to do is we were given a y term earlier. So we have this y term, and that's what we started with. We can go ahead and back substitute that y term into our solution. So we have the first term that we started out with, which is y, and then we have our last three terms, which is what we got during our derivative. And so now we have our full solution for y prime.